Alright, this is section 10.6, and we've already talked about a tangent. We're going to talk about, that's not us, I don't think. We're going to talk about a tangent again, but we're going to introduce something else. And let's just talk about it. Let's define it first, and then we'll show you how it works and that good stuff. So let's put a circle right here. Remember from yesterday, the tangent hits the circle at one point, right? Doesn't go through the circle. Alright, it just hits the circle at one point, that's all it does. But this time we're going to draw a line that does what? What do you think?
Hits 2 points on the circle.
Okay, hits 2 points on the circle or goes through the circle. Okay, either way you want to look at it, right? That's fine. Alright, so there you go. And we have a name for that. Alright, we call it a secant. Alright, that's how we say it. I guess you could say secant, but we usually just kind of do it fast. Secant. Alright, so it's a secant, and that's what that is. Alright, it's a line. And it doesn't have to go through the center of the circle. It could. All right, it doesn't have to. It could just, as long as it hits the circle. And how many points? 2 points. All right, hits right here and it hits right here. That means it's going through the circle. If it only hits at 1 point, then it's not a secant. What is it if it only hits at 1 point? It's got to be a tangent. Okay, if it hits at no points, it's nothing. Right? It's a line that has nothing to do with a circle. Right? If it doesn't, yeah, I guess it is unimportant. Well, all lines are important. We don't want to make them feel bad. All right. So anyway, but it doesn't have anything to do with the circle. So that's called a secant. Pretty simple. There's not a whole lot to that, but there are some things that we're going to do, some examples and things like that. So let's go to the first theorem. All right. Now what we're going to do is draw two secants, okay, that actually intersect each other inside the circle. Now, it looks like in that theorem, they have it intersecting at the center, but it doesn't have to intersect at the center, okay? It looks like it is in that theorem if you look in the book. It doesn't have to intersect in the center, but you have two secants that intersect inside the circle, okay? So, there you go. Does that look like two secants that intersect inside the circle? Yeah, it does to me, all right? And look what it does. Creates some angles in here. Now, we know something already from way back. You know vertical angles, all right? And that's about it, okay? So what's true about this? It's what? 360. What about 360? Yeah, they all add up to 360. Yeah, they all add up to 360. Okay, all the arcs also, right, add up to 360 because it's a whole circle. But what's true about this angle and this angle right here? They're equal to each other because of vertical angles. And same thing with this angle and this angle right here. We good with that? What I want to look at is not just those angles, because we've already discussed that. Now, I'm not too good at tracing this, so I might be off. It's no big deal. I want to talk about the arc that it creates. Do you see this angle right here? It's creating this arc. It cuts off. Listen, please. This angle creates this arc. Don't worry about the artwork here, okay? We're not going to worry about that. Let's just pay attention to what I'm trying to teach you. So these angles right here, or this angle right here, creates this arc. You with me? This angle right here creates this arc. Now look at the two arcs. Do the two arcs look like they have the same measurement? No, this one goes way further, or this one goes way further around than what this does. So just because this angle is equal to this angle, does it mean that the two arcs are going to be equal to each other? No, obviously not. Now, what if, I just thought of this, what if those two lines, those two secants intersected at the center? Then they would be central angles, wouldn't they? And then what would be true about the arcs? Then they would be equal to each other. Does that make sense? Because they're cutting off the same, it's the same angle, it's a central angle. Remember, the angle is equal to the arc, all right? So they would be the same degrees. But we don't have that situation here. Here's what we have. Let's label these things so it makes it a little bit easier. We'll call this A and B, and we'll call this one C right here. The C is that point, you understand? And this is D, all right? And let's see. Let's name this by a number. It's a little easier since we got these other letters. We'll just name it by a number. We'll just call it angle 1. Is that all right? So this angle 1 right here, if I was going to take this arc and this arc, now they're definitely not equal to each other, but this angle is equal to the half of the sum of the arcs, which means this. If I took AB and added it to DC, okay, that angle's right there is not going to equal to that number, because that would be a pretty big number, and there's no way that that angle's that big. What it would do, though, if I take that and split it in half, kind of average them, right? This angle right here is basically the average of these two arcs, if you want to think of it that way. All right? So watch. Let's write that down. So angle 1 equals half of the sum of the intercepted arcs. Alright, so what are the intercepted arcs? AB, arc AB, and what else? DC or CD, however you want to write it. Like that. And that's what angle 1 is equal to. Does that make any sense? Alright, so let me see what example they do. I'm just going to make, I'm going to use the numbers from the book, okay? I don't know if this is to scale or not. It probably isn't. That's okay. Alright, we're just going to do what we've got. So let's say that's 84 degrees. Again, it might not be to scale. We're okay with that though, aren't we? Let's say that's 84 degrees, and let's say this is 130 degrees. I'm just using the numbers from the book. You can look in the book. That probably is to scale, but this is not. And I wanted to find out what angle 1 is equal to. Well, it's actually a pretty easy thing to do. What do? You add those two up. So watch the math. It's 130 plus 84, and then what do you do with those two? Yeah, divide it by 2 or take half of it. I like to divide it by 2, don't you? Alright, so what's 130 plus 84? It's 214. Divide that by 2, and what's that? It's 107, okay? That probably isn't too far off, okay, but it's not bad. So this angle right here, we'll just put that is 107 degrees. Make that angle 1 into a 1. Alright, that's all there is to it. It's not so hard, is it? Now it gets a little bit trickier if, watch, let's say they don't tell you this, and they'll call it X, and they give you this angle. Right? Now what would you do? Yeah, you would say 107 equals, what? Let's do it like this. I like to put it over 2. Do you like over 2 better than a half out in front? I do. I like to put it over 2. So let's do it like that. So this angle is equal to the sum of these divided by 2. So what is it? X plus 84. Now you can do a little bit of algebra, can't you? Get rid of the 2. Now you know what it's going to come out to be, but I'm just showing you. And that's what? X plus 84. Alright, subtract 84 from both sides. And look what you get. And what is that? 130, I guess, right? Yep. So X is 130. So you could go either way, couldn't you? Alright, if they give you the 2 arcs, you could find the angle. If they give you the angle in one arc, you could find the other arc, and so on. Yes?
Which one would you assign the 1 to? Like,
It's in between these two. So the angle 1 was in between these two lines, so that's the only thing that angle 1 could be. So if I put like a 2 here,
I mean, what about the vertical angle?
well, it's the same thing. This angle and this angle would be the exact same thing. Because if you do the math, watch, this angle, let's call this 3, alright? It would be the same thing as angle 1, the original angle 1, because look, this arc and this arc, you're still adding them up and taking half, right? So you're going to get the same exact thing, because this arc cuts off this one, and this angle, or I'm sorry, this angle cuts off this arc, and this angle cuts off this arc, alright? So we've got, they're going to be exactly the same. So 3 and 1 will be the same, and whatever we get for 2, that and that would be the same as well. Make sense? Alright. Okay, now what I'm going to do is we're not going to go just with 2 secants. Remember, that was 2 secants that intersect inside the circle. Alright? We're going to have all kinds of variety of different things going on here. What if I had a tangent? We talked about tangent yesterday, but let's say I had a tangent. Okay, there's a nice little tangent right there. And let's say I had a secant. Let's see how they word this. If they intersected the point of tangency. Okay, what if I had a secant that intersects this tangent at the point of tangency? Does that make sense? Alright, so I'm going to have a tangent, not like this, but where? About right there. Okay, where it hits. Does that make sense? In fact, I'm going to actually take this and put it right at the point of tangency. You okay with that? Alright, I've got a tangent and I have a secant. Now let's see what angle we have formed right here. Let's call this one, let's call this angle right here, let's just call it, let's go to a different color. I don't know, let's just call it angle 2, because angle 1 sometimes it looks just like a little mark. It doesn't look like it really belongs. So we'll just call this angle 2 right here. Alright? So what we're going to do here, I'll tell you what, hang on just a second. Okay, this angle right here, remember what we did earlier with that, let's go a little bit thicker with this line. Look what arc this cuts off, angle 2. See, it's got this secant, it's got this tangent. Look at the arc that's cut off by that angle. Now I don't have it marked, I don't have it labeled or anything, but it's basically right there, isn't it? Okay. I was going to go to this brush tool because it's a little bit thicker. Alright, that's good right there. So look at that arc that it cuts off. Well, this angle, now this angle actually goes beyond that circle just a little bit, doesn't it? All right, but that's okay. This angle right here is exactly half of this arc. All right, so the angle, so angle 2, I guess I should label this. Let's label it QNE. All right, so, and we'll put a D out here. All right,
Yes.
just for Ryan. So watch, angle 2 is actually equal to half the arc. What is the arc? It's QE. All right, and it's also, and this angle right, or this angle 3 right here is half of this arc, QDE. You see it?
What?